probably took some kind of intelligence test at some point, a school assessment, an online quiz, maybe a formal IQ test, and somewhere in your life, a number got attached to your name, a number that was supposed to tell you how smart you are, how capable, how far you could go. But the real answer to what that number actually means is far stranger than anyone told you. Because that number is not fixed. It never was. And the people who figured that out first did not wait for science to confirm it. They just got to work. Think about the smartest people you have ever heard of. Einstein, Da Vinci, Ramanujan. You probably imagine them as born different, wired differently from the rest of us, touched by something the rest of us were not. That story feels true. It is also almost entirely wrong. What actually separated them was not raw intelligence. It was what they did with their mind every single day. And modern neuroscience has now caught up to prove it. In 1988, a neuroscientist named Marion Diamond published findings that would quietly rattle the scientific world. She had been studying brain tissue for years, and what she found was this: the brain is not a fixed machine. It changes. It physically restructures itself in response to experience, to challenge, to the demands you place on it. She called this neuroplasticity, and at the time, many of her colleagues thought she was wrong. She was not wrong. Your brain contains roughly 86 billion neurons. Each one connects to thousands of others, and every time you learn something new, every time you push through confusion, every time you sit with a hard problem and refuse to let go, those connections strengthen. New ones form. Weak ones fade. The architecture of your intelligence is being rewritten constantly, right now, in real time. This is not a metaphor. This is structural biology. So where did the idea of fixed IQ even come from? In the early 1900s, a French psychologist named Alfred Binet designed the first intelligence test. His goal was narrow: identify children in Paris who needed extra support in school. He never intended the test to measure a ceiling. He never believed it captured the full range of human ability. In fact, Binet explicitly warned that his scale should not be used to label children as permanently limited. Then his test crossed the Atlantic, and everything changed. American researchers took Binet's tool, renamed it the IQ test, and began using it to rank, sort, and categorize millions of people. The number became destiny. Schools used it, governments used it, employers used it, and a generation of people were told, quietly or loudly, that their ceiling had already been decided. But here is what those researchers missed. The brain you have today is not the brain you were born with. And it is not the brain you will have in 5 years, not if you use it right. Psychologist Carol Dweck spent decades studying why some people improve and others plateau. What she found was not about talent, it was about belief. People who believed their intelligence was fixed stopped taking risks. They avoided challenges. They interpreted failure as evidence of their limit. But people who believed their intelligence could grow did the opposite. They leaned into difficulty. They treated confusion as a signal to push harder. And over time, they measurably outperformed people who started with higher test scores. Dweck called this the growth mindset. But it is more than a mindset. It is a neurological reality. When you believe you can grow, you behave differently. You attempt harder problems. You stay in discomfort longer. You seek feedback instead of avoiding it. And each of those behaviors directly stimulates the brain structures responsible for learning. The anterior cingulate cortex, the prefrontal cortex, the hippocampus. You are not just thinking differently. You are physically building a more capable brain. Now here is where it gets specific. Because geniuses are not just people who believe they can grow. They are people who have figured out exactly how to train. The first thing they do is something researchers call deliberate practice. Not repetition, not just doing something over and over. Deliberate practice means targeting your exact edge of ability, pushing just past it, failing in controlled ways, and adjusting. Anders Ericsson, a cognitive psychologist at Florida State University, spent his career studying world-class performers, violinists, chess grandmasters, surgeons, athletes. And what he found was consistent. The ones at the top were not practicing more than everyone else. They were practicing differently. They were working in the zone just beyond their current ability. Comfortable practice does not build skill. Uncomfortable practice does. Your brain does not improve when things are easy. It improves when things are hard enough to require new solutions. The second method geniuses do is something you probably undervalue. They rest strategically. This sounds like permission to be lazy. It is not. During deep rest, particularly slow-wave sleep, the brain replays and consolidates what it learned during the day. Connections strengthen. Patterns crystallize. What felt like confusion before sleep often resolves into clarity after it. Da Vinci was famous for taking short naps throughout the day, sometimes with a key in his hand, so the sound of it dropping would wake him at the edge of sleep, that hypnagogic state between waking and dreaming. He claimed his best ideas came from those moments. Modern neuroscience now has an explanation for why. The third method is the one most people skip entirely. They train attention, not knowledge, not skill. Attention itself, because attention is the mechanism through which all learning happens. If your attention is fractured, no amount of information will stick, and attention, it turns out, is trainable. A 2011 study by Sara Lazar at Harvard Medical School found that people who practiced mindfulness meditation for an average of 27 minutes a day showed measurable increases in cortical thickness in the prefrontal cortex, the region most associated with working memory, decision-making, and focused thought. 27 minutes, not years of practice, weeks. And the structural change was visible on an MRI. What geniuses have always done intuitively, science can now describe precisely. They protect their attention like a resource. They go deep on one problem before shifting to another. They build what some researchers now call cognitive depth, the ability to hold complexity in mind long enough to find connections others miss. The fourth method is cross-domain thinking. Einstein played violin. Feynman drew and played bongo drums. Darwin was obsessed with earthworms and barnacles alongside his theory of evolution. This was not coincidence, and it was not hobby. Cross-domain thinking forces the brain to build analogical bridges, pathways that connect concepts from different fields. Those bridges become the source of the most unexpected insights. When you only ever think within one domain, your solutions are limited to what that domain already knows. When you think across domains, you start importing solutions from places no one in your field thought to look. The fifth method is the one that feels most uncomfortable. They actively seek out what they do not know. Most people spend their intellectual energy reinforcing what they already understand. It feels good, it confirms competence, but it does not build intelligence. The brain grows at its edges, not at its center. Geniuses have always been almost pathologically curious about their own ignorance. Socrates built an entire philosophy around it. Feynman had a notebook he called his Book of Things I Do Not Know. Darwin kept meticulous records of every observation that contradicted his own theory. Your confusion is not a sign of weakness. It is a map of exactly where your brain has room to grow. None of this means that genetics play no role. They do. Baseline processing speed, working memory capacity, certain perceptual abilities, all of these have a heritable component. But heritability is not destiny. A genetic predisposition is a starting point, not a ceiling. And the research is increasingly clear that the gap between someone with a modest genetic baseline who trains their mind deliberately and someone with a high genetic baseline who never challenges themselves can be enormous. And it runs in one direction. The deliberate one wins. Over time, almost always. So here's the reframe. When you sat down and took that test, when a number was attached to your name and you carried it forward as a fact about yourself, you were not being measured. You were being photographed, a snapshot of your brain at that moment, not a prophecy, not a ceiling, a single frame in a very long film. The film is still running. Every hard problem you sit with, every skill you push past your edge to acquire, every night of deep sleep and every hour of genuine focused attention, you are adding frames. You are changing what the next photograph will show. The geniuses you admire were not born on a different planet. They were built, slowly, by the choices they made about what to do with their minds. And the same mechanism that built theirs is running in you right now, waiting to be used. The number was never the point. What you do next is.